within west-central Oregon, is a strange geologic oddity. In the vicinity of the young Blue Lake crater volcano plus the Sand Mountain and Belknap crater lava fields are a strange group of two buttes. These two buttes have unusually steep sides surpassing 45 degrees in some areas, an unusually flat top, but most importantly are clearly composed of volcanic rock. Known as Hogg Rock and Hayrick Butte, these features are both vents of subglacial volcanoes that formed during the last ice age. Tuya volcanoes. They are known as tuyas as this type of volcanic landform first received their name from the flat-topped Tuya Butte in British Columbia. These spectacular landforms are quite fascinating, especially because they are typically found in areas with Arctic-like climates such as Iceland, Alaska, and far northern Canada. Although Hayrick Butte and the smaller Hogg Rock are quite spectacular, they are merely a fraction of the size of the Togiak Tuya in Alaska, and the Hartubreath Tuya in Iceland, which has a prominence of 3,280 feet. Yet, all of these landforms formed in the same manner, albeit involving different thicknesses of ice. So, how and when did these two subglacial volcanoes form? Before I explain this, I must note that we are currently not sure which volcanic complex these two tuyas are a part of. Several papers suggest they are associated with different volcanoes, such as the extinct Three-Fingered Jack, Mount Washington, or even the Three Sisters volcanic complex. The current science is inconclusive, so for the purposes of this video I will present the two tuyas as a distinct albeit dormant volcanic complex. Although this complex has not erupted for many tens of thousands of years, I cannot definitively rate it as extinct due to our incomplete knowledge of the region. While tuyas can form from lavas with a wide range of compositions, they tend to form via low silica basaltic composition lava, much like you would find at Kilauea in the Hawaiian island chain. However, the 980-meter-long and 740-meter-wide Hogg Rock and the 1,400-meter-long and 1,200-meter-wide Hayrick Butte are not formed out of basalt but rather a type of lava more typically associated with stratovolcanoes such as the Three Sisters complex due to its grey color, andesite. Age of the tuyas. The Hogg Rock tuya formed between 100,000 and 50,000 years ago, while the age of Hayrick Butte is uncertain. However, Hayrick Butte appears to be about the same age as Hogg Rock, so it is safe to say that they formed within 20,000 years of one another. Whichever one formed first, their joint formation began around 75,000 years ago due to an offshore plate collision. There, the Juan de Fuca plate was colliding with and subducting underneath the North American plate. The melted material from this collision then migrated upwards until it erupted onto the surface, forming a chain of volcanoes. When the first eruption occurred, large swaths of what are the Cathead Range were covered with thick glaciers that likely surpassed as much as 1,000 to 2,000 feet thick. Oregon was much colder, and had a climate more similar to central British Columbia, which is how such massive ice sheets grew at naturally cold high points. As magma erupted into a thick ice sheet, it initially formed a layer of material which tuya formation looked much like a dome out of pillow lava. However, since eruptive activity continued for long enough, it breached the top of the overlying glacier. As eruptive activity continued, the heat melted significant volumes of ice, creating a thick glacial lake around the volcano. After the glacial lake developed, eruptive activity shifted to a more explosive phase, depositing a rock type known as hyaloclastite. Over time, the erupting vent, which now had an unusually steep profile, breached the surface of the lake, causing eruptive activity to change once again. Instead of being highly explosive, more effusive to moderately explosive eruptive activity occurred, sending lava flows to fill the area previously occupied by the lake. The movement of the lava was partially constrained by the presence of the glacier, forming an incredibly steep slope at its edge. After the glacier retreated, the highly unusual volcanic feature became visible for all to see. Conclusion. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank my new YouTube member Mercelin Gono for supporting this channel.